Hello and welcome to the World War Lab channel. Today's story takes us deep into the Pacific theater of World War II, to a moment when one unexpected visitor would quietly change the future of long-range air combat. June 26, 1944, Hollandia Air Base, Dutch New Guinea. A game of checkers sat unfinished on a small table as Lieutenant Colonel Charles MacDonald lifted his eyes from the board. The man standing in the doorway of the screen recreation hut had already introduced himself, but the name had not fully registered. MacDonald's attention was still on the match he was playing with Lieutenant Colonel Merrill Smith, the operations officer Satan's Angels. The civilian calmly repeated his name, his voice steady and self-assured, and this time it made MacDonald pause. Charles Lindbergh, the Charles Lindbergh, America's most famous aviator, was standing thousands of miles from home in a makeshift base, asking permission to talk about P-38 combat operations. Neither man realized in that instant that this brief interruption would transform long-range fighter tactics across the Pacific. Over the next 6 weeks, the techniques Lindbergh would introduce would extend the combat radius of the Lockheed P-38 Lightning by nearly 400 miles, turning what pilots once believed impossible into routine operating procedure. The account of how a civilian consultant nearly doubled the effective range of America's premier twin-engine fighter is not just a technical story. It is a narrative about resistance within institutions being overcome by undeniable results, about pilots learning to trust mathematics more than instinct, and about how one man's specialized understanding of fuel efficiency reshaped aerial warfare in the Pacific. The formulas for extended range were not being written in engineering textbooks, but in the daily experiences of pilots who slowly discovered that everything they had been taught about engine management was incomplete. What had once been unthinkable was about to become standard practice, guided by a 42-year-old civilian who had flown a P-38 for the first time only 3 days earlier. The path that led to that screen door in Hollandia had begun 17 years earlier, high above the Atlantic Ocean. From May 20th to May 21st, 1927, Charles Augustus Lindbergh changed aviation history by flying alone from New York to Paris, a distance of 3,600 miles in 33.5 hours. The Ryan NYP monoplane he piloted, the Spirit of St. Louis, carried 450 gallons of fuel in tanks so massive they completely blocked his forward view. Lindbergh navigated using a periscope and dead reckoning, managing fuel consumption with a level of precision that many pilots of the era would have considered excessive or even obsessive. When he landed at Le Bourget Field, he still had 85 gallons of fuel remaining, having achieved a level of efficiency that experts believed impossible for a Wright Whirlwind radial engine. That relentless focus on fuel management became the cornerstone of Lindbergh's technical identity. Throughout the 1930s, while conducting survey flights for Pan American Airways across both the Pacific and the Atlantic, Lindbergh refined methods that pushed aircraft range far beyond what manufacturers claimed possible. He understood that published performance figures were averages, not absolute limits. Every engine had a precise operating zone where power output, fuel consumption, and mechanical strain existed in perfect balance. Discovering that zone required a deep understanding of how manifold pressure, propeller RPM, mixture control, and indicated airspeed interacted in ways that exceeded standard pilot training. By 1944, Lindbergh had become one of the world's foremost authorities on long-range flight, but his relationship with the U.S. military had grown complicated due to his outspoken isolationist views before the war. He had passionately opposed American involvement in European conflicts, led the America First Committee, and earned the hostility of President Franklin Roosevelt. On April 29, 1941, after Roosevelt publicly compared him to Civil War Confederate sympathizer Clement Vallandigham, Lindbergh resigned his commission as a colonel in the Army Air Corps Reserve. When the attack on Pearl Harbor forced the United States into war, Lindbergh tried to return to military service. Roosevelt personally made sure that Lindbergh would never again wear an American uniform during the conflict. But expertise always finds another path. Barred from serving as an officer, Lindbergh became a civilian technical consultant for aircraft manufacturers. In 1943, he joined United Aircraft Corporation, where he worked extensively with their Chancellor Division, the producers of the F-4U Corsair. He also spent time at Ford's Willow Run plant helping solve production problems with the B-24 Liberator. He flew dangerous high-altitude test missions in P-47 Thunderbolts to analyze engine performance and contributed to the development of dive bombing techniques for Corsair. His technical impact was immense, yet Lindbergh still longed to experience combat firsthand. By early 1944, he recognized opportunity. United Aircraft wanted to evaluate the feasibility of a new twin-engine fighter, and the only American aircraft fitting that category was the Lockheed P-38 Lightning. Lindbergh persuaded the company to send him to the Pacific as a technical representative to observe P-38 operations under real combat conditions. On April 3, 1944, he began preparing for deployment to the South Pacific. He stopped at Brooks Brothers in New York to buy a naval officer's uniform without insignia. At Brentano's bookstore, he purchased a small New Testament, writing in his journal, "Said I can only carry one book, and a very small one. That is my choice." It would not have been a decade ago, but the more I learned and the more I read, the less competition it has. He departed San Diego on April 24th, officially bound for Marine Corps aviation bases in the South Pacific near Guadalcanal. The Navy Department authorized the trip, but it was kept secret from the White House. Neither President Roosevelt nor even Secretary of the Navy Frank Knox knew Lindbergh was heading into a combat zone. What was intended as a purely observational mission soon evolved into something more when Marine aviation officers invited him to fly as an observer on combat sorties. On May 21, 1944, Lindbergh flew his first combat mission, a strafing run with Marine Fighting Squadron 222 against a Japanese garrison near Rabaul. The Marines called it observation, but Lindbergh flew with his guns armed, engaging targets whenever the chance arose. He quickly proved that his knowledge was not merely theoretical. Working with Corsair pilots, he demonstrated how to safely take off with bomb loads nearly double the F-4S rated capacity. The Marines had been losing aircraft due to overweight takeoff accidents. Lindbergh carefully analyzed power settings, takeoff speeds, and weight distribution, showing them how precise control of these variables could prevent disaster. His approach combined mathematical discipline with practical flying experience, revealing that many long-accepted limits were not as fixed as pilots believed. Distribution reduced accidents while increasing strike capability. News traveled quickly across the Pacific theater that the legendary aviator was flying combat missions as a civilian and solving operational problems that had frustrated military pilots for months. By mid-June of 1944, Lindbergh had turned his attention to the P-38 Lightning. United Aircraft's interest in twin-engine fighters was genuine, but Lindbergh had also heard that the 475th Fighter Group, known as Satan's Angels, was one of the most aggressive and successful Lightning units in the Pacific. If he truly wanted to understand the P-38, that was where he needed to be. On June 15, 1944, Lindbergh caught a ride to Finchafen, New Guinea. From there, he announced his presence at 5th Air Force Headquarters at Nadzab, where he had lunch with Colonel Marion Cooper. On Sunday evening, June 18th, he dined with General Ennis Whitehead, discussing developments in New Guinea and his intention to observe P-38 operations firsthand. The authorization he received was informal, unofficial, and technically insufficient by strict military standards. But in the fluid command environment of the Southwest Pacific, personal relationships and demonstrated expertise often carried more weight than formal paperwork. On June 20th, Lindbergh spent 1 hour and 20 minutes checking out an AP-38 with the 35th Squadron of the 8th Fighter Group. It was his first time flying the distinctive twin-boom fighter. 6 days later, on June 26, he flew to Hollandia and walked into Lieutenant Colonel MacDonald's recreation hut, interrupting the unfinished game of checkers. MacDonald was only 29 years old and already a 10-victory ace. He commanded the 475th Fighter Group, which had been activated in Australia on May 14, 1943, and had since become one of the highest-scoring P-38 units in the Pacific. The group's three squadrons, the 431st, 432nd, and 433rd, flew the latest P-38J models, equipped with improved intercoolers and increased fuel capacity. These Lightnings were the longest-range fighters in theater, capable of missions no other aircraft could attempt. Even so, their operational radius was still restricted. Long-distance missions left little fuel for combat maneuvering, and pilots frequently returned with dangerously low reserves. Several aircraft had already been lost when bad weather forced detours that exceeded their fuel limits. At first, McDonald politely dismissed Lindbergh and turned back to his game. But when Lindbergh mentioned that General Hutchinson, commander of the 3rd Air Task Force, had sent him to discuss P-38 combat operations, McDonald took notice. After a brief conversation, he asked Lindbergh if he would like to fly a mission the following day. Lindbergh accepted without hesitation. The mission would launch at dawn. Instead of returning to headquarters, McDonald suggested Lindbergh stay at the 475th camp to avoid transportation issues. As Lindbergh settled into a spare cot, word spread rapidly throughout the unit. Charles Lindbergh was flying with Satan's angels. Reactions among the pilots were mixed. Lieutenant John Purdy of the 433rd Squadron was eager to meet the famous aviator. Others were skeptical. Some questioned whether a 42-year-old civilian, regardless of his reputation, could handle modern air combat. Major Thomas McGuire, already a 15 victory ace who would later finish the war as America's second highest scoring fighter pilot with 38 confirmed kills, was especially curious to see what the old man could do. On the morning of June 27, 1944, Lindbergh prepared for his first P-38 combat mission. The weather was miserable, with steady rain falling at 5:30 a.m. Conditions improved slowly, and by 10:30 the flight finally took off. McDonald led 4 aircraft toward Jeffman Island and Sam 8 Airfield, regular targets for the 475th. Lindbergh flew as Blue 3 on McGuire's wing. The 4th aircraft was piloted by Merrill Smith, already an 8 victory ace. McDonald watched Lindbergh slide effortlessly into perfect formation on McGuire's wing. For someone who had only checked out in the P-38 days earlier, his formation flying was flawless. The mission called for strafing an enemy barge in Cabot's Bay. Lindbergh weaved through anti-aircraft fire, his cannon and machine guns tearing into the target. The mission was successful, and all 4 aircraft returned safely. But what truly caught attention came after landing. When the crew chiefs inspected Lindbergh's aircraft, they began to notice a pattern. His P-38 consistently returned with far more fuel remaining than the aircraft flown by other pilots on identical missions. After a 6.5-hour armed reconnaissance mission on July 1st at enemy airstrips along the western shore of Geelvink Bay, Lindbergh landed with 210 gallons of fuel still on board. Other pilots from the same mission came back with gauges hovering near empty. On July 3rd, the group escorted 16B, 25 bombers on a strike against Jeffman Island. After the bombing run, the Lightnings went barge hunting. Within an hour, 2 pilots reported critical fuel levels and turned back. Lindbergh continued flying, his gauges still showing comfortable reserves. McDonald noticed a growing discrepancy and called a meeting. Just 2 days after Lindbergh's arrival, he gathered all the pilots of the 475th in their recreation hall. The building was crude, with packed dirt floors beneath a palm-thatched roof. A single ping-pong table and a few decks of cards made up most of the furnishings. Bare light bulbs hung overhead, casting a harsh glare on the room. McDonald got straight to the point. He formally introduced Lindbergh and asked him to explain how he was able to return from every mission with more fuel than anyone else in the group. What followed would reshape P-38 operations across the entire Pacific theater. Lindbergh stood before the assembled pilots and explained the cruise control techniques he had developed for the Lightning. Standard operating procedure taught P-38 pilots to cruise at 2,200 to 2,400 revolutions per minute with the mixture set to auto-rich. This setting delivered solid power and was considered safe for the engines, but it not as extreme as pilots feared. Aircraft and engines were replaceable. Experienced pilots were not. That reality shaped his thinking as he worked with the 475th. He understood that calculated risk, supported by evidence, could save lives rather than endanger them. Lindbergh explained that the standard cruise setting of 2,200 revolutions per minute with a mixture in auto-rich was designed around safety margins and simplicity, not efficiency. It was a one-size-fits-all solution meant to prevent engine damage, even if pilots were careless with temperature and pressure limits. But in doing so, it sacrificed enormous amounts of potential range. By reducing engine speed from 2,200 revolutions per minute down to 1,600 revolutions per minute, switching the mixture from auto-rich to auto-lean, and slightly increasing manifold pressure to compensate for the lower revolutions, pilots could dramatically reduce fuel consumption without sacrificing useful cruise speed. His recommended setting was precise: 1,600 revolutions per minute, 30 inches of mercury manifold pressure, mixture in auto-lean, and an indicated airspeed of about 185 miles per hour. At these values, fuel consumption dropped to roughly 70 gallons per hour, producing an efficiency of approximately 2.6 miles per gallon. Compared to standard cruise configuration, which burned far more fuel for only marginal gains in speed, the savings were enormous. Lindbergh calculated that these changes alone could extend the P-38's combat radius by nearly 400 miles and make 9-hour missions practical. When he finished explaining, half an hour after he had begun, the room remained quiet. The pilots sat in silence, processing what they had just heard. A 9-hour flight was a disturbing thought for men who already considered 7-hour missions brutal. The cockpit of the P-38 was cramped. Pilots sat on their parachutes, with an emergency raft and survival gear crammed beneath them. Their flight suits were heavy and uncomfortable. Even 7 hours in that environment pushed physical endurance to the limit. 9 hours sounded almost impossible. Even more unsettling was Lindbergh's recommendation to operate engines in a regime pilots had been trained to avoid. The combination of low RPM and high manifold pressure was known as running oversquare. Military training stressed that oversquare operation was dangerous. Pilots were taught that it caused detonation, overheating cylinder heads, and eventually catastrophic engine failure. They were warned that if manifold pressure exceeded RPM by more than a small margin, they risked destroying their engines. Now the civilian consultant was telling them to make such settings standard practice. The skepticism in the room was unmistakable. Pilots exchanged uneasy glances. Some shook their heads. One openly said that Lindbergh's method was dangerous. But McDonald saw something different. Lindbergh was not presenting theory. He had already flown combat missions using these settings. His aircraft had not suffered engine damage. It consistently returned with fuel reserves that no one else could match. That alone demanded serious attention. McDonald decided the only way to settle the issue was through direct testing. If the method worked, the 475th would gain a massive operational advantage. If it failed, they would discover it quickly. Over the next week, pilots cautiously began experimenting with Lindbergh's cruise configuration. The first flights were short, designed so they could return immediately if any sign of engine trouble appeared. The earliest reports were nervous but encouraging. Pilots said the engine sounded different at 1,600 revolutions per minute. The deep, steady roar of the Allison B-1710s changed in tone, becoming heavier and slower. But the gauges told a reassuring story. Oil pressure stayed within normal limits. Temperature readings remained stable. Cylinder head temperatures, the key warning sign for detonation, were actually lower than at higher RPM settings. Instead of overheating, the engines were running cooler. As confidence increased, pilots began using the new technique on longer missions. The results were impossible to ignore. Fuel savings were dramatic. Missions that once forced immediate return after strike could now include extended combat air patrols. Flights that required constant fuel anxiety ended with comfortable reserves. The P-38's effective combat radius, previously around 570 miles, pushed out to 700, then 750 miles. Pilots found they could reach targets that had once been considered beyond the Lightning's reach, fight over the area for 15 minutes, and still return home with a full hour of fuel remaining. The transformation was extraordinary. Skepticism faded as mission after mission confirmed the results. Lindbergh flew regularly with the 475th, building combat hours and teaching by example. He led formations, proving that the civilian observer could handle combat just as effectively as any uniformed pilot. When he was in command of flight, his call sign was simple and unmistakable: Mr. Lindbergh. He took time to explain the physics behind the technique, so pilots could understand why it worked rather than simply trusting it blindly. Aircraft engines generate power by burning fuel to create pressure that drives pistons. Fuel consumption depends on how much fuel is burned per unit of time. The goal is to generate the required power while burning as little fuel as possible. Traditional high RPM cruise settings produce more power than necessary and wasted fuel because the engine was cycling rapidly, burning fuel with each combustion stroke. By lowering RPM and increasing manifold pressure, the same power output could be achieved with fewer combustion cycles, each one using fuel more efficiently. The auto-lean mixture setting further improved efficiency by delivering just enough fuel for complete combustion, rather than the excess fuel used in auto-rich mode to cool the engine during high-power operation. The engines did not detonate because, although the settings were technically oversquare by ratio, the actual power output was moderate. A manifold pressure of 30 inches was far below the 60 inches used for war emergency power during takeoff and combat. In fact, the lower RPM reduced mechanical stress on the engine's internal components. The technique was not dangerous. It was simply different from what pilots had been taught. Lindbergh's confidence came from a lifetime of experience with long-range flight. His Atlantic crossing in 1927 had taught him that published performance figures were starting points, not limits. His work with Pan American Airways in the 1930s, surveying trans-Pacific and transatlantic routes, had given him thousands of hours to experiment with fuel management under real operating conditions. The P-38 had one major advantage that made experimentation less risky than it appeared: two engines. If one engine suffered damage while testing these cruise techniques, the second engine could still bring the aircraft home. Over the vast Pacific, where mechanical failure usually meant death by drowning or capture by the Japanese, pilots and single-engine fighters had no such margin for error and naturally flew conservatively. The P-38's redundancy created a safety buffer that allowed careful exploration of its true performance envelope. Lindbergh also understood the broader reality of the war. Aircraft and engines could be replaced. Experienced combat pilots could not. His methods, though unconventional, were designed to preserve both fuel and lives and give American air power a reach the enemy would never expect. Acceptable. Allison was shipping spare V-1710 engines and parts to the Pacific in generous quantities. If an engine required replacement after experimental operation, ground crews could install a fresh power plant quickly. The operational advantage gained from extended range justified accepting a small risk of increased engine wear. In the end, that calculation proved correct. No P-38 engines failed as a result of Lindbergh's cruise techniques. By late July of 1944, Lindbergh's methods were spreading throughout 5th Air Force P-38 units. The success of the 475th Fighter Group was impossible to ignore. Word moved from squadron to squadron. Pilots compared notes. Ground crews shared fuel consumption figures. Other commanders wanted the same advantage that Satan's angels now possessed. Lindbergh gave additional briefings to pilots from other groups, patiently explaining the procedure, answering technical questions, and addressing lingering fears about engine safety. Adoption was not instant or universal, but it was steady and unstoppable. July 28, 1944 marked Lindbergh's most dramatic combat moment with the 475th. The mission was a bomber escort to the Sarmy area, flying with the 433rd Squadron. Lindbergh flew as Blue 3 in a four-ship formation over LPD Bay. Blue Flight encountered enemy aircraft, two Mitsubishi Ki-51 Sonya, light bombers returning from a search mission. These aircraft, used for reconnaissance and ground attack, belonged to the 73rd Independent Flying Chutai. One was flown by the unit's commanding officer, Captain Saburo Shimada. The other was piloted by Sergeant Yakogi. The American fighters attacked immediately. On paper, the outcome should have been simple. The Sonyas were slower, less maneuverable, and lightly armed compared to the P-38 Lightnings. They were completely outclassed. But Captain Shimada was an experienced pilot who had no intention of dying without a fight, and the engagement turned into a running battle. P-38s from the 9th Fighter Squadron had engaged the Sonyas first, and the fight was already in progress when McDonald's flight arrived. Shimada's wingman, Sergeant Yakogi, was hit by cannon fire from Lieutenant Wade Lewis. The Sonya's left wing caught fire. As the damaged aircraft tried to flee, Lieutenant J.C. has slipped in behind it and fired a long burst. Smoke streamed from the stricken bomber as it dove into the sea. Shimada's aircraft continued alone. For nearly 30 minutes, the Japanese captain outmaneuvered multiple attacking P-38s. He threw his plane into violent turns, the wingtips trailing condensation as he pushed the Sonya to its limits. American pilots tried to pull lead and line up a shot, but they could not hold their aim. The slower Japanese aircraft could turn inside the faster American fighters. Captain Danforth Miller, McDonald wingman, briefly managed to place the Sonya in his gun sight, but lost it as Shimada completed a hard left turn. Miller's tracers passed almost 80 feet behind the target. Then Shimada did something no one expected. Instead of continuing to evade, he turned directly toward Lindbergh. The two aircraft raced toward each other head-on at a closing speed of nearly 500 miles per hour. For Lindbergh, a man who had logged thousands of flight hours but had never before faced an enemy aircraft intent on killing him, the moment sharpened into terrifying clarity. Shimada held his course. Whether he intended to ram or hoped to trade gunfire in a final act of defiance, he committed fully to the collision path. Lindbergh instinctively aimed at the Sonya's radial engine and squeezed the trigger. The P-38's concentrated nose armament, one 20mm cannon, and .50 caliber machine guns erupted in a 6-second burst. He held the trigger down as bullets and shells slammed into the front of the Japanese aircraft. The Sonya's propeller visibly slowed. Smoke poured from the engine, yet Shimada still did not break away. At the last instant, Lindbergh pulled up violently. His P-38 passed over the damaged bomber, with only feet to spare. Shimada's aircraft plunged into a steep dive. Other lightnings added short bursts of fire. The Sonya continued downward, trailing smoke until it struck the ocean at high speed. A tall plume of white spray erupted from the impact. Foam spread outward in widening circles, then slowly dissolved back into the sea, leaving the surface as calm as before. Captain Saburo Shimada and his observer were dead. Back at base, the kill was discussed quietly. Several pilots had hit the aircraft. McDonald, Miller, and Lindbergh had all scored strikes. But it was Lindbergh's head-on burst that had mortally wounded the Sonya, slowing the propeller and initiating the fatal dive. Unofficially, the pilots agreed among themselves. Lindbergh had scored his first and only aerial victory. It was never entered into the 475th's official combat record. Lindbergh was a civilian, and his presence in combat was already highly irregular. Recording an official kill would raise questions that could end his time with the unit immediately. 3 days later, on August 1st, Lindbergh nearly lost his life. The mission was a fighter sweep to the Palau Islands. The flight encountered Japanese Zeros, and in the resulting dogfight, Lindbergh found himself locked in a turning battle with a Zero pilot who came dangerously close to shooting him down. Only McDonald's urgent radio call, "Brake right, followed by his own aggressive attack on the Zero, saved Lindbergh's life. That close call convinced 5th Air Force Headquarters that the experiment had gone far enough. Lindbergh had proven his techniques beyond any doubt. He had flown roughly 50 combat missions in the Pacific, including about 25 in P-38s with the 475th. He had helped transform long-range fighter operations. He had shot down an enemy aircraft, and he had nearly been killed. It was time to send him home before something irreversible happened. On August 12, 1944, Lindbergh departed Hollandia to return to the United States. The pilots of the 475th Fighter Group gathered to see him off. Their respect for the civilian technical representative was genuine. He had not only taught them methods that extended their combat reach, he had flown beside them, fought beside them, and proven himself in the one environment where rank, titles, and fame meant nothing at all. The impact of Lindbergh's fuel efficiency techniques extended far beyond the 475th Fighter Group. By October 1944, P-38 units across the entire Pacific were using variations of his cruise control settings. The exact numbers differed slightly depending on unit practices, aircraft condition, and weather, but the principle remained the same everywhere. Lower RPM, higher manifold pressure, and a leaner mixture working together to dramatically increase range. The operational consequences were enormous. Targets that had once been out of reach suddenly became accessible. Japanese bases that had previously been safe from fighter escort were now within range of P-38s that could arrive with enough fuel to fight and still return home. Bombers that once flew unescorted, or not at all, could now be protected. Long-range fighter sweeps penetrated deeper into Japanese-held territory than ever before. In Dutch New Guinea, P-38 groups were soon flying missions of 950 miles to their targets, fighting for 15 minutes over the objective, and still returning safely to base. Before Lindbergh's techniques, such missions would have been unthinkable. The increase in range was not a minor improvement. During the second half of 1944, the expanded combat radius directly supported General MacArthur's advance toward the Philippines. Airfields that previously could not be supported by fighter coverage suddenly became viable forward bases. Invasion plans that had required long delays while closer airfields were built could now proceed immediately. The strategic effect was measured not only in miles, but in time. Operations that would have taken months were completed in weeks because fighter protection could move faster and reach farther. The technique also saved lives. Pilots who once returned with fuel gauges reading empty now landed with usable reserves. Bad weather that forced long detours no longer meant certain loss of aircraft. Pilots who took damage in combat had a much better chance of reaching friendly territory. The additional fuel margin directly reduced non-combat losses and gave crews a buffer that often meant the difference between survival and disaster. The extended range proved especially critical during the liberation of the Philippines. When MacArthur's forces landed on Leyte in October 1944, P-38s flying from bases in New Guinea and Morotai provided fighter cover over distances that would have been impossible only months earlier. The difference between arriving over the target with no reserve fuel and arriving with an hour's supply meant the difference between effective protection and symbolic presence. Fighters could remain on station, engage enemy aircraft, and still return safely. Yet adoption of Lindbergh's methods was not without resistance. Some commanders worried about long-term engine reliability. Some pilots trusted their formal training more than the advice of a civilian, no matter how famous. Maintenance officers feared accelerated were on already overworked engines. But the evidence kept piling up. Units using Lindbergh's techniques reported no increase in engine failures. Fuel consumption figures showed undeniable improvements. Mission reports described successes that would previously have been impossible. Results outweighed theory. By late 1944, Lindbergh's cruise control method was officially incorporated into P-38 operating procedures. What had begun as a civilian consultant's observation became formal doctrine. The U.S. Army Air Forces issued revised cruise charts for the P-38 that reflected Lindbergh's findings. Pilot training materials were updated to include proper lean-of-peak mixture operation. What had once been considered dangerous became standard practice. The larger story of Lindbergh's Pacific service revealed a man driven by complex and often conflicting motivations. Before the war, his isolationist views had made him deeply controversial. His comments on German aviation technology had earned him accusations of sympathy toward Nazi Germany. His outspoken opposition to American entry into the war had destroyed his relationship with President Roosevelt. When the United States finally entered the conflict, Lindbergh found himself a political outcast despite being one of the most accomplished aviators in the nation. But in the Pacific, far from Washington and its politics, Lindbergh found something close to redemption through technical competence and personal courage. Marine and Army Air Force pilots judged him not by his political opinions, but by how well he flew and whether his ideas worked. Major Richard Bong, America's highest-scoring ace with 40 confirmed victories, later told a United Press reporter that Lindbergh was as hot a pilot as any of us, adding that he would have been knocking off Japs every day if General Kenny had let him. Praise from a pilot of Bong's stature carried more weight than any political rehabilitation ever could. Lindbergh had proven himself in the one place where reputation meant nothing and results meant everything. After returning to the United States in mid-August 1944, Lindbergh continued contributing to the war effort. In October, he participated in a joint Army-Navy conference on fighter aircraft performance at Naval Air Station Patuxent River, Maryland. He flew and evaluated captured Japanese aircraft, providing valuable insight into enemy capabilities. He continued working as a consultant for United Aircraft and other manufacturers, helping solve problems that appeared during combat operations. The technical details of what Lindbergh achieved reveal the scale of his impact. The P-38J Lightning carried approximately 410 gallons of internal fuel in its standard configuration, with two 90-gallon main tanks, two 60-gallon reserve tanks, and two 55-gallon leading-edge tanks, along with provisions for external drop tanks. Total capacity could exceed 1,000 gallons. At the standard cruise setting of 2,200 revolutions per minute with mixture and auto-rich, fuel consumption was high, varying by source but far greater than under Lindbergh's method. His cruise technique reduced total consumption to roughly 70 gallons per hour. The combat radius increased from about 570 miles to approximately 750 miles with the same allowances for combat and reserve fuel, an improvement of more than 30%. For maximum range missions, additional drop tanks combined with his cruise settings allowed flights approaching 9 hours and distances exceeding 1,000 miles. These capabilities reshaped Pacific air operations. The island-hopping campaign that defined MacArthur's advance through New Guinea and toward the Philippines depended entirely on air superiority at each step. Fighter range determined which islands could be invaded, which airfield could be defended, and how fast the front line could move, could be bypassed, and which required direct assault in order to secure airfields. By extending fighter range, Lindbergh's techniques enabled far bolder operational planning. Islands that would have demanded costly amphibious landings could instead be skipped, because fighters could now reach targets from more distant bases. The strategic map of the Pacific changed, not because new aircraft had been built, but because existing aircraft were finally being flown to their true potential. Some historians later confused Lindbergh's range extension work with the famous April 1943 mission that intercepted and shot down Japanese Admiral Isoroku Yamamoto's transport aircraft. That operation, flown by P-38s from the 339th Fighter Squadron base on Guadalcanal, had indeed pushed the Lightning's range to its limits. But Lindbergh had nothing to do with that mission. He would not arrive in the Pacific for more than a year afterward. What he contributed was not a single extraordinary flight, but the ability to make such extreme-range missions routine rather than exceptional. The human dimension of Lindbergh's achievement deserves special emphasis. He was 42 years old when he deployed to the Pacific, flying combat missions against enemy pilots often 20 years younger than himself. The physical demands of high-G maneuvering, the stress of combat, and the discomfort of 7 to 9 hour flights in a cramped cockpit all took their toll. Yet, Lindbergh never asked for special treatment. He flew the same missions, accepted the same risks, and followed the same procedures as the young lieutenants and captains who made up most of the 475th. His willingness to demonstrate his techniques personally was essential to their acceptance. Had he remained safely at headquarters and simply lectured about fuel management, pilots would have dismissed him as another theorist who did not understand combat realities. By flying and repeatedly proving that his methods worked, he earned credibility that neither rank nor fame alone could have provided. The psychological effect of Lindbergh's success went beyond fuel efficiency. He demonstrated that civilian technical expertise could have real value in combat operations. Military organizations naturally prioritize rank and combat experience, but modern warfare required technical sophistication that often existed outside the formal chain of command. Lindbergh proved that civilians with specialized knowledge could significantly improve combat effectiveness if given the chance. His success encouraged commanders to listen more closely to civilian representatives from aircraft manufacturers, engine companies, and research organizations. That improved cooperation between military operators and civilian developers accelerated technical innovation throughout the war. The P-38 Lightning itself also deserves recognition for enabling Lindbergh's work. Its twin-engine design provided a redundancy that made experimentation safer. The Allison V-1710 engines, though sometimes criticized for their limitations, responded well to careful mixture control. The P-38's complex fuel system, with multiple tanks and transfer pumps, allowed precise fuel management. Its stability made it well suited for long-duration cruise flight. By late 1944 and early 1945, the P-38 was being replaced in some theaters by the P-51 Mustang, which offered superior high-altitude performance and longer range with the same fuel load. But in the Pacific, the P-38 remained valuable until the end of the war. Its twin engines offered safety over open ocean. Its concentrated nose armament delivered devastating firepower. Its maneuverability at low and medium altitudes matched Pacific combat conditions. And its range, especially when flown using Lindbergh's techniques, remained exceptional. The final statistics reflect its impact. The 475th Fighter Group, flying P-38s exclusively, achieved 551 aerial victories, making it the highest-scoring P-38 unit of the war. America's second highest-scoring ace, Major Thomas McGuire with 38 victories, flew Lightnings with the 475th. The aircraft's combination of range, firepower, and reliability made it one of the dominant fighters in the Pacific, and the extended range made possible by Lindbergh's methods enhanced every aspect of its effectiveness. Missions could reach farther, fight longer, and return with greater safety. The cumulative effect across thousands of sorties and hundreds of thousands of flight hours was immense, even if impossible to measure precisely. The story also reveals the uneasy relationship between expertise and institutions. Lindbergh's pre-war political positions had made him unwelcome in official military service. President Roosevelt's personal opposition prevented him from serving in uniform. Yet the Army Air Forces desperately needed exactly the kind of knowledge Lindbergh possessed. The compromise that emerged, unofficial civilian status with informal authorization to participate in combat, was irregular and would almost certainly violate modern regulations. But it worked. Institutional rigidity gave way to operational necessity, and the war effort benefited enormously. The men who flew with Lindbergh in 1944 never forgot him. In interviews conducted decades later, former pilots of the 475th spoke with deep respect for civilians who had flown as their equal and taught them how to fly farther than they believed possible. Colonel Warren Lewis, who commanded the 432nd Squadron, could still recall Lindbergh's fuel-saving settings in precise detail many years later. The exact numbers varied slightly in different recollections, reflecting adaptation to specific conditions and aircraft, but the principle was always the same, and the results were unquestionable. Charles Augustus Lindbergh died on August 26, 1974, at the age of 72 from lymphoma at his home in Kipalulu, Maui. He had quietly left Columbia Presbyterian Medical Center in New York on August 17th and arrived in Maui just 1 week before his death. He was buried about 3 hours after passing in a simple handmade coffin built by Hawaiian ranch cowboys wearing their work clothes, in a grave 30 feet deep, lined with lava rock and black beach pebbles at the Palapalahoomo Church Cemetery. Only 15 people attended. The grave marker is a simple concrete slab bearing a line from Psalm 139, "If I take the wings of the morning and dwell in the uttermost parts of the sea." His wartime journals, published in 1970, provided detailed accounts of his Pacific service, including his time with the 475th. The legacy of Lindbergh's work in the Pacific extended far beyond the specific techniques he introduced. He demonstrated principles that remain relevant in any era of warfare. Technical expertise matters in combat operations. Civilian specialists can make meaningful contributions if they are given the opportunity. Institutional procedures should always be questioned and improved when evidence supports change. Personal demonstration is more persuasive than abstract theory. And perhaps most importantly, there is always room for improvement, even in systems that appear to be fully developed and refined. In the final analysis, Lindbergh's achievement in the Pacific represented a rare intersection of specialized knowledge and operation necessity. The Pacific theater demanded extreme range from fighter aircraft. Existing procedures limited that range well below what the P-38 was technically capable of achieving. Lindbergh possessed a unique understanding of fuel management, developed through decades of focus on efficiency. He had the opportunity to apply that expertise under combat conditions where results could be measured objectively. He had the courage to demonstrate his ideas personally, risking his own life to prove that his methods worked. And he approached the pilots as an equal, never relying on his fame or reputation to demand acceptance. The story of German prisoners of war witnessing American industrial power showed how overwhelming material evidence could transform beliefs. Lindbergh's story shows how technical mastery, proven in practice, could transform combat capability. Both reveal that some of the greatest victories are achieved not through brute force, but through knowledge applied with precision and proven by example. The German prisoners returned home knowing that democratic prosperity could create abundance. The American fighter pilots who learned from Lindbergh gained techniques that multiplied their effectiveness while increasing their chances of survival. The P-38 Lightning flew on until the end of the war, its distinctive twin-boom silhouette becoming a symbol of American air power in the Pacific. The pilots who flew it remembered the aircraft with affection despite its quirks and challenges. And those who flew it in 1944 also remember the civilian who taught them that the impossible was often merely difficult, that published limits were starting points rather than boundaries, and that true understanding could unlock capabilities hidden in plain sight. That was Lindbergh's Pacific legacy. Not the combat victories, not the missions flown, but the knowledge he shared and the techniques he taught. He arrived as an observer and left as a teacher. He came as a celebrity and departed as a comrade. He transformed an aircraft's capabilities through nothing more than understanding how it truly worked and having the courage to prove that better methods existed. The pilots of Satan's angels knew exactly what Lindbergh had given them. They flew farther, fought longer, and returned home more safely because of knowledge shared freely by a civilian who understood fuel efficiency better than anyone else in the Pacific. That knowledge, proven in combat and adopted throughout the theater, stands as one of the most successful technical innovations of the Pacific Air War. And it did not come from laboratories or engineering departments, but from one man's specialized mastery of an art he had perfected 17 years earlier over the Atlantic Ocean. That mastery, applied in a different context and with different aircraft, proved just as valuable in 1944 as it had been in 1927. The principle never changed. Understand the aircraft completely, manage resources precisely, and never accept that published limits are absolute limits. Lindbergh lived by that principle, and for 6 weeks in the summer of 1944, he taught it to some of the finest fighter pilots in the Pacific. They, in turn, passed it on to others, spreading knowledge that reshaped how America fought the air war in the Pacific.